Okay, the first thing new here is you're going to start to see this symbol show up. This symbol here looks like a 0 with a line through it. This is theta. And theta is just a Greek letter. It's nothing special, just like the Greek letter T. What do we use it for? I know it looks a little intimidating, but it's just going to be used exactly like x. We're going to use theta to represent an angle when we don't know the measure of an angle. We use it the exact same way as x. You might think, why don't we just use x? And the reason is because we've already used x for so many other things. They want to come up with something different for our angles. So we'll start seeing this in pictures like this one, where the theta here represents an angle where we don't know the measure. That's all, nothing special, don't have to freak out. Okay, so in this picture, we're going to try to identify our sides. We want to identify the opposite, adjacent, and hypotenuse. So what we need to do is for each side, we're going to identify the sides as opposite, adjacent, hypotenuse. And we'll write one of 3 letters. We're just going to write O, A, or H. So the first thing you want to do in these problems, start off by identifying the hypotenuse. It's usually the easiest side. It's across from the 90-degree angle, usually farthest away from it. That side across from the 90-degree angle, that's the biggest side, the slanty side. That's the side we call the hypotenuse. We're going to identify it and just write the letter H there for hypotenuse. The other 2 sides of the legs, they make the 90-degree angle. One of them is the opposite, O, and one of them is the adjacent, A. It's easier to spot A. A, the adjacent side, which adjacent just means next to, is the side next to our selected angle. Now our angle in this case has been selected for us. We've got this little mark here saying that this is the angle we're using. We want the side that's next to our angle. The adjacent side simply connects this angle to the 90 degrees. So that side on the bottom here is our adjacent. It's next to our selected angle. The last side is called the opposite. We use the letter O to represent that. It's a side that's across from our angle, the side farthest away from it. That's the opposite. So our 3 sides are O, A, and H. Try it again. All right, in this triangle, we have our angle selected for us. We see the theta in that angle and the marking there. We got 3 sides to identify, O, A, and H. Start by identifying H, the hypotenuse. That's the long slanty side. It's across from the right angle. That's going to be our hypotenuse. So, start by putting an H there for hypotenuse. The other 2 sides, the legs, one of them is opposite, one of them is adjacent. Adjacent connects our angle to the 90-degree angle. That's down here. And the 3rd side, the last side that's away from our angle, is the opposite. Do this again. Here, the angle's up on top, but we still do the same thing. The hypotenuse is across from the 90 degrees. That's our H. The adjacent angle connects our marked angle to the 90 degrees, so that's A. And the opposite side is far away from our angle, all the way down there. Let's see. And again, it's kind of getting repetitive and hopefully very easy. In this triangle, identify O, A, and H. Step 1, the hypotenuse is across from the right angle. That's our H. The adjacent side connects our angle to the 90 degrees. That's A. The opposite side is the side across from our angle, all the way on the other side of the triangle. Label that one O. All right, that is O, A, and H. Next, we're going to talk about, whoa, well, I guess it's going to be in a different video here. Hang on. Now, the other thing we have to be able to do is solve simple algebra problems. But the nice thing, when we do trigonometry, our next unit, all of our algebra problems are going to look the same, at least in the beginning. They're all going to look like this. We're going to have some decimal is equal to some fraction. And we'll start with having x on the top of the fraction for all of them. It'll be x over some number. I don't know what that number is going to be. It'll change from problem to problem. Now, the numbers don't really mean much here, but we're going to have to be able to solve this kind of problem over and over and over again. The nice thing is, it's really simple. This says that x divided by 28 is equal to this decimal. So if we want to get x by itself, we got to get rid of this divided by 28. So we would simply multiply both sides by 28. In this case, on the right, they simply cancel each other out. We just have equals x. On the left side, you get a calculation, hopefully a really simple one that you can do in your calculator. You do 28 times 0.1837. And here in this case, we're going to get 5.1436. You're going to have the same problem over and over and over again, or at least it's going to look the same setup, and should be the same 2 steps to solve the problem each time. Let's just take a look at one other one, and we can be done. Oops. Oh, I guess I'll have to do it on another page. So the same kind of problem where we'll have some weird decimal, 0.7281 is equal to x over 14. In this case, same thing. If we're trying to solve for x, we have to get rid of this divided by 14. Really simple to do that. We just multiply both sides by that 14 so they cancel out. On the left side, you have a small calculation. Hopefully you got a calculator. If not, you can just go to Google and just type in a math problem. Google will turn into a calculator for you. So 14 times 0.7281, we should get 10.1934 is equal to x. All right, those are the 2 types of problems we are practicing today.